welcome to my channel. Thank you for visiting this video. So I would like to explain a little bit about the geospatial analysis. Selamat datang ke channel saya Kerja Data Online. Please consider to subscribe, like and share all our videos. We provide a very comprehensive online courses free of charge. Nonton semua video kami sehingga akhir pembelajaran secara percuma. So today my focus and topic is more towards the what we call it as explain about univariate local Moran's eye. So before we further understand about this analysis, let me give you some insight. What is local Moran's eye? So local Moran's eye is actually multivariate analysis involving the spatial component to see is there any relatedness of the spatial in terms of the locations. In this particular case, in our example after this, is basically we want to know whether the district and also the spatially condition of areas is related or not towards a certain thing, health crisis in our country. Okay, so let us have a look about the data set. So I have the data here. Unfortunately, data is not up to date due to the fact that I retrieve it from the secondary sources, from the Ministry of Health website and also from the media. So I really hope that ladies and gentlemen outside there with regard and have this particular data to share with me, and then we can help together in terms of analyzing the spread of the disease together. If you think that this mechanism and also this idea may not suitable or may not be applicable, so you can still use it for another purpose, especially for mapping the resource allocation and so on. Okay, let us dive into the analysis. So this is the Malaysian according to the different district. This map actually being gathered from the MACD. MACD is my geo databases. It's from the surveyor point of view. So I retrieve this data, I retrieve this map, and I have inserted one data that is very crucial here for our analysis today. Is called as a total 20 March 20. So actually the case or the data set is already being gathered from the secondary sources, as I mentioned to you before. So details can be used even though you have the data that you can update accordingly. Okay, so first of all, for those who are interested to run this analysis, you have to install this free software. We call it as Geoda. So Geoda is one of the free software developed by Arizona State University in America. So basically, we can just open it and then we open any Esri shapefile. So in this case, I got this shapefile. This shapefile also available in the description below. You can just download it free of charge. Okay, so the first step is actually you want to see the data. You can go to this table and then you can have a look about the data set here. So this is our data, indicate the total number of cases according to the different district in 20 March 2020. So if you got the latest one, the first step when you run this univariate local Moran's eye, you must really understand what is the function. So local Moran's eye is actually looking into the spatial condition of the cases, whether it is scattered randomly or it is not scattered randomly. So our null hypothesis will be the cases is actually being randomly assigned or randomly happening in our country. And then our alternative hypothesis will be the specific cases is actually not random. That means they are being clustered. Okay, they are being positioned in some places due to the certain condition, due to certain demographic factors and also spatial element that influence this disease to be concentrated in one particular cases, in one particular place. Okay, so to run this analysis, you need this Geoda. And then when you receive this Geoda, you can install it using Macintosh, using Windows, and also Linux. They made available all of that by just visiting the website here, Geoda. Geoda. Okay, when you go to Geoda, you can just go to download and then you can download accordingly. It is one of the group that is already utilized this free software for make such important tools for spatial epidemiology. Okay, so let us dive in. To update your data, if you got this file, you can download it, you can use by your own. And I really hope that you can share the data, but if you want to run the data by your own, you can just proceed with the table here and then right click, and then you can add variables. Okay, under the add variable, you can go to the integer and then you can insert the total number of cases. So today is 25th March 2020. I failed to have specific by district cases, so therefore I made this video just to make sure that I still in this week and update it accordingly. So after you update it, then you can run a few analysis. So tonight I specifically want to share with you the what we call it as the univariate local Moran's I for spatial autocorrelation. Okay, let us dive to the analysis part. So the first one, you need to have the weighted. You need to have the weighted. Weighted is actually functioning to indicate the neighboring region of our district from one district to another district. So you have to create it if you don't have, and then I already specify it under UPI, unique parcel identifier. So you can just use the UPI by go to this create, and then you can go to UPI, and then you can click create just to save those weight element. So my data actually already saved, so therefore I just have to load it. Okay, this is district case queen.gal. I'm just going to open it, and then it is loaded, and then if you can see, this is the histogram indicate how many regions available in each of the district. For example, this one is 9 to 10. There are at least a few districts that have 9 to. So after that, you can also use the connectivity map to see what is the area is being connected to which area and bahagian. In Sabah and Sarawak we call it as bahagian. Okay, this is very important, especially if you are environmental health officer, to identify your political boundaries and so on. Okay, this is the connectivity map and so on. So you can dive in, but to just simplify this video, I'm just going to give you the idea about this univariate local Moran's I statistics. Okay, so the first of all, you have to use the weight. After you load the weight, then you proceed with the time, space. You go to the space, and then you proceed with the univariate local Moran's I. And then I'm going to specify as tot 21 March 20. So please bear in mind, this is the cases, the total cases, each of the district in 20 March 2020. So the weight will be the specific weight. And then I'm going to click OK, and then request for significant map and also Moran scatter plot. Okay, this is the output that will be produced by the Geoda, and then I'm going to give you the idea about all this map and how to understand and interpret it accordingly. Okay, so first of all, this is our map. We have 4 quadrants of this map. I just click here to indicate those quadrants so that you understand it a little bit. Okay, this is called high quadrant. This is the first high quadrant. High quadrants means that these particular cases is actually being clustered into a specific location. Okay, it is already being specified under this quadrant. This is high. Okay, this is low. This is low. Okay, low is under this quadrant. High means that these cases is high when compared to their neighboring mean condition of that area. You know, this is partial autocorrelation. We call about high, or we call it as the hotspot. This is what we call it as a cold spot. And then another quadrant, this one and this one, we call it as a spatial outlier. So spatial outlier is a very important mechanism, especially if you want to look any abnormalities or any abnormally that happening in our data set. So usually our focus as epidemiology, we are focusing on the high-low, which is indicate the location in the quadrant here, where we want to address a certain condition where is the location that having high values of cases, but being surrounded by a few districts that is very low. So this is called spatial outlier. So this is also spatial outlier. This is called low high. Low high, on the other hand, is actually indicate how well or how good, or we can also justify it as what happening in this area where it's recorded very significantly low cases, whereby the neighboring region is actually indicated very high cases. So based on the Moran's eye statistics here, we can see that the level is more than 0.3. It suggests a positive spatial autocorrelation happened. That's mean the cases are being clustered, So the null hypothesis is already being rejected, and then we can suggest that there is a cluster happening in our cases. So to measure those cluster or not, we can refer to this LISA significant map on this area. Okay, so we got three different p-value, the probability value. So this is the first one, the probability of the 0.05, where you have a confidence level to reject your null hypothesis and indicate that this is the area which is, we call it as partially significant. That's mean if we look into these 10 areas, we can see that at least all of these hot spot and cold spot is significant. Its significance means that is showing some statistical meaning. Same also goes to this p-value, which is much more significant, and then the last but not least is very high, significant enough in this region. So using the geoda, actually it can help you to map out and also to give you some idea what is the resource that need to be set, what is the learning mechanism, or what will we take into consideration when we want to deploy the resource, or when we want to deploy the law enforcement officer or the specialist to cater this kind of disease or health crisis. So when you look into this, we can see that at least we have 6 high or we call it as hotspot area, and then using the geoda, when you click those high, actually it is automatically selected the region or the area for that particular cases. That's why, in my humble opinion, very specify these diseases based on the district, so that we can make some sort of spatial analysis to identify is there any relationship with the other factors that may relate to the resource setting, to the management of this disease, to relocate the patient under investigation, patient under surveillance, and so on. So this is very useful, especially in the planning stage and also at the execution level. So if you can see here, majority of the cases reported to be spelled out in this area: Kuala Lumpur, Petaling, Hulu Langat, Gombak, Klang, and also Kuala Selangor. So this is just the example of high, which is, we call it as a hotspot. In the other terms, we call it as a hotspot. It is very useful if you can use the geoda, so you can map it, and then you can make a further arrangement of your resource to these specific areas, so that more meaningful health crisis issues can be mitigated early. So I hope that this short video and comprehensive explanation can give you some ideas about spatial analysis in epidemiology. So if you got any questions or any discussions that you may want to discuss, please don't forget to just comment in this video. Please share the information, especially the statistical data. It's very useful for us to help you, giving you some insight and also some ideas about this issue. Okay, that's all. Thank you guys.